Welcome everybody, and for those of you that know me or those of you that don't know me, hope to get to know you today through this webinar, and I hope that all of you are comfortable sitting in a nice quiet place and have your nice cup of coffee, tea, or your favorite beverage with you and relax, and I'll be talking about Elenos, about our technology, and about the high power transmitters. So we may get into some other areas, but this seminar will be mainly focused on the high power transmitters. So for that, let me talk a little bit about some of our transmitters that are actually already installed for several years. This technology has been around for a while, and a lot of you know us as a manufacturer of low to medium power transmitters from 1 to 5 kilowatt. So we're going to be talking a little bit more about some of the higher power, like for example over here, if you can see my arrow, this is a 10 kilowatt, here's a 15 kilowatt shipping. This is in the US. We have a 10 kilowatt here in mid-America. This is a 15 kilowatt that shipped into Asia. Here's one that went into Indonesia with dual exciters, a 10 kilowatt. I believe this is a 20 or a 25, probably a 20 kilowatt here with Danelli Prosperini, who's our manager of customer service. Here's a checkout at Elenos in manufacturing of one of the higher power systems. And then finally, we have another one also at Elenos here in the factory. So I should also point out that we do on occasion have opportunities for higher power, even up to 40 kilowatts. Our standard offerings for the high power line are from 10, there's actually a 10, 15, 20, 25, 30, but we also occasionally do some things above that. And for example, this one is in Eastern Europe, and it's a 40 kilowatt, and it's operational today. A little bit about Elenos. A lot of you know us already. Started in the late 70s, last century, I guess. And we've grown with over 40,000 transmitters shipped to over 100 countries. So we're on the move. A lot of you know us, and we'd like to share the new technology, what we're doing. So down in this range here from 150 to now 2 kilowatt and actually beyond, if some of you have attended the Broadcast Asia show or NAB, we have our 2RU series here, and then 2.5, 3.5, and 5 kilowatt is 4RU. These are very, very popular models, very compact. And then, but today we'll be talking about the 10, 15, 20, 25, and 30. And there's a lot of similarities between these, and the common ground will be a basic building block of scalability that I'll refer to. So for now, I want to talk a little bit about our technology and what makes Elenos different for those that are not very familiar with us as a company. I put in a few things here in this presentation that I thought were very important. And being in this business for several years, more than I want to really admit right now, I have to say that one of the really unique things we do is we make our own power supplies, and our power supplies are designed to be FM transmitter power supplies. So therefore, there's a lot of unique things about them. We do have a white paper that's available about our power supplies. You can read about them. I don't know if it's available on the web page, but certainly you can talk to your sales manager in your region, and he can get you a copy of the white paper that talks about our power supplies. Probably the most significant difference between Elenos and a lot of the other equipment out there is planar technology. Now, we see a lot of planar technology being used in various industries and of course in broadcast. And Elenos has been working with planar technology to some extent since the 90s, actually. So we're very familiar with it, and it's really a key ingredient of our technology in that it reduces the number of parts. I'm not going to read all the slides, but and then the words from here, but what's really important is that this is a major difference in reliability. There's not a lot of adjustments that have to be done in the factory. The technology and performance remains consistent because of planar technology, and that there's not a lot of adjustments that can wander off in one area that need to be fixed and adjusted from time to time. Along with this, we get the added deal of increased efficiency, which is something we'll be talking about quite a bit today. Another thing that we do that's quite unique is we tropicalize all our boards. Now, a lot of you come from areas of the world, parts of South America, Latin America, from Africa, Middle East, different parts of Asia where tropicalization is really important. So we'll talk a little bit about this technology and what we do really mechanically and what we do to the electrical assets in our products so that they can remain running for extended periods of time and to our expectations and beyond. I'm going to go right into 3 areas and talk about some of our main technologies. IceFet, which is really quite cool, eco savings, and life extender. So there's a little intro of why we're different. Here's a shot of the planar technology, and as you can see, it's clean. It's really clean. When you open up an Elenos transmitter, you don't see a lot of wires and semi-rigid coax and so forth. It's very, very clean design, and if I take the arrow here, look at my RF here, and then here's my combiner, and I've got some more slides on that I'll show briefly. But IceFet technology has nothing to do with ice, but has everything to do with running the transmitter system. Very cool. It's our philosophy, okay, about how we run our RF sections and how we control other parts of the system to feed this the RF portion of our radios, okay. So basically we run at very low temperatures, and this, what it does is basically allows us to be very efficient, allows us to be able to maintain within specification, good quality, continuous, and at the same time good audio quality as well. So at the same time, we also are able to increase the lifetime of the product by running at lower temperatures. So one thing, when I visited Elenos the first time and took some infrared shots of some of the transmitters, I was absolutely amazed. Now, if you look at this slide here, this is actually a 2 kilowatt, so it's very compact, and that section there, the scale goes from 23 to 45.9 Celsius. And the section there is actually the RF section, the MOSFETs there running at 41 degrees Celsius. So taking a look at normally the MOSFETs are designed to go much higher, but in our case, because of we're underutilizing the power of the MOSFETs, and through our cooling systems and through some controls, we're able to keep the temperature down. So this is really important in our design. The next thing to talk about is eco savings, and what's interesting is I started a group on LinkedIn called Green Broadcasting, and if you're interested, you can find it on LinkedIn. But ironically, most people are interested in saving money to run their stations rather than the economy. Than to deal with basically the ecology of our world. But you get 2 here. This is a win-win situation. You save money, and also you contribute to saving energy for the planet. So again, a win-win situation is what we call our eco savings. Here's a good example, and let's get down to what is the most important part. Now, what I'm going to do is talk about mainly from 10, 15, and 20 kilowatt, which I have in this chart. This chart was made from a program on the web called the NAB Calc, okay, and I picked average cost of 15 cents per kilowatt hour. Now, in your part of the world, it may be double that, it may be less than that. It's hard to tell. But these calcs, and this basically was done from this point of view. So I took 3 brands, and I took Elenos, and ran these calculations. They were all the same, and you can see that this is the cost per year. So let's look at a 10 kilowatt, and brand B is running $26,800 a year, which is which is pretty common if you're running something in the mid-50s, something like that. Then you look at brand H is quite a bit better, and brand N is the best out of what we're comparing to. Now ours, 10 kilowatt, or our ET10000, is running under $20,000 based on this criteria per year. So when I compare it in these two columns here per year and every 10 years, I'm comparing against the best one. In this case, it's brand N, and the savings is $2,459 a year over this brand. Okay, so the lifetime savings, if you consider 10 years, is what we expect the minimum for a transmitter to be in service. You're looking at $25,000. So, you know, big savings here. You're considering operating costs in some of these higher powers, or through operating costs, you're basically going to get back your capital expense. So this, as engineers, this is something you can take to your finance managers and station managers and so forth, and it's really a great selling point, the efficiency of products. So we'll get into that a little bit more as we talk about the individual products. Life extender, our trademark, is something I'm pretty excited about. I really like the idea about having the power supplies, the PA devices, the controller, everything, the audio sections, all being able to talk to each other. And through this system of algorithms and between hardware and software, we're able to allow the transmitter to run safe even in rugged environments. So if we're running in a very hot temperature because we've lost our AC, or if we're running in a very humid environment, we're still able to continue in these tough, rugged environments. So life extender is something that's the technology is really a bunch of algorithms, how we tie together the system, and through our controller, how we manage the different subsystems of our transmitters. So with that, here's some examples, and another beauty of life extender, which I'm really excited about. If I have life extender, I also have a scale for the day where I can adjust and run maybe 100% of the power during peak broadcast hours, or at nighttime I can drop off and run at 50%, 75%, whatever I want. But a 24/7 calendar here, which you can adjust. And I really like this idea because I really think that in a real world, we can save even more money by running lower power. And one thing that's really important with our technology and with the life extender is that we run at the same efficiency, whether it's 10% of the maximum power or with 100% of the power. Okay, moving on. Another important feature, at least in this part of the world, I think the worst corrosive area is New Zealand and in parts of Australia, where it's actually, the environment is very, very difficult on the equipment with rust. So our design is, for the most part, aluminum chassis design, and we're designed really to withstand a lot of these dissimilar metal situations. So again, this is a part of the technology that goes from our smallest 150 watt all the way up to 40 kilowatts or 30 kilowatts in our high power range. Here's an example of a couple of power supplies. Now, the one on top there is a smaller one that you would see in a smaller range product or in an exciter that's part of your part of the high power system. Or to the bottom here, which is the mainstay 3 kilowatt, which is an integral part of the building block of our high power system. So there's more on that to be shown, and I'll show you how that all goes together. Okay, so now we're going to move on away from the other products and the technology and everything good and great about Elenos, and we're going to talk about our high power transmitters. So this picture is a view looking at the exciters down on a 20 kilowatt transmitter in a 19-inch rack. So let's talk about the concept. And the concept is based on a grandiose idea from our founder, Leonardo Bussi. And he's pictured there with his ETG 5000. Many of you are very familiar with this product. Okay, so the ETG 5000 is and that technology and everything in it is the building block for our high-power systems. And here on the right here is basically our power amplifier, which is the first building block of components in our high-power system. So the ETG 5000 has a built-in exciter. The power amplifier of 5 kilowatts that I'll talk about is exactly the same without the exciter. Okay, so the scalability, and here's just an example. I believe this is a 20 kilowatt, but our scalability can give us a range from 10 to 30 depending upon how we put in these amplifiers. So again, we have a 5 kilowatt amplifier number 1, 2, 3, 4, do the math, easy, 20 kilowatt there, okay? In this particular rack, the other building blocks we'll be talking about are the exciters, and we can have a single exciter or dual exciters. You can have a backup there. In this particular case, at the 20 kilowatt, we're a little bit different. We have a combiner separate from what we call our controller power box. And very important part of this also is to have some sort of dummy load for high power, as well as a breaker box. The breaker box is really simple. I invite you at some point to take a look at youtube.com, and there's a real nice video showing the installation of a 10 kilowatt. And I'll tell you, the video lasts about 7 to 10 minutes, and it's a complete installation. And in fact, one of our customers from Cambodia just recently installed a 10 kilowatt out of the crate, boom, boom, up and on the air quickly. So from there, let's talk about scalability. Okay, and scalability comes, as I mentioned, with the 5 kilowatt amplifier. So we'll stay on the amplifier for now. For our U size, okay, the weight's about 38 kilograms per power amplifier. The energy savings for this device is 74 to 75%. So the ETG 5000 is very, very efficient design. So maximum 7.5 kilowatts of power from this device. The next thing to talk about is, okay, what do we do? Again, we're overutilizing, again, the amount of power that we feed into this. So if we need 7.5 kilowatts of power to run this at max, we've got 9 kilowatts in there. Each of these individual AC power supplies are 3 kilowatts. So 9 kilowatts to support the 7.5 that's required maximum. So again, part of our design philosophy. We're going to take a look again here and a little bit more about some of our design. You can see how clean this is. If you look here, here's our MOSFET section and power amps inside the individual 5 kilowatt combiner technology. If you look here in the back, I go right into my low-pass filter. And then on the right here is inside that box over here to the left, there's our low-pass filter design. So everything clean here and out to the RF flange into the antenna. On the exciter technology, I'm going to address what's been available and what's available right now and our migration. So this is a typical exciter. Actually, this is probably a little bit more overstuffed than an exciter that we may use. This is probably a 2 kilowatt. I'm not really sure here, but this would be used as an exciter. But you can see the exciter section over here, which is all the audio circuitry here. As part of the exciter, we have the typical left-right inputs, MPX inputs, AES-DBU if you care to, and so forth. So also a lot of the other connections associated with audio and with FCA, RDS inputs are also part of the exciter technology. Now to the right is something really exciting and new, and you should be on the lookout for it right now. In its way into migration is our new digital direct-to-channel exciters. And it's really a point to talk about that this is going to migrate itself into all our product lines as an option, and then eventually probably a standard. With the digital exciter direct-to-channel, we start seeing even more consistency and than analog. But so I just wanted to introduce that today as exciters, as being part of this overall building blocks for the high power transmitters. And next part, we talk about the combiner controller unit, and this is either in a 4-rack unit or it could be in a couple of different units depending upon how much power. As we get into 20, 25, and 30 kilowatt, we need to do this in a couple of modules because it's just not possible physically to do that. But basically, if you look at the 10 kilowatts, real simple if we do the math, we have two. Basically, it's a 2 by 5, 15, 3 by, and then go up to a 30 kilowatt. We have a 6-way combiner. Okay, the combiner in this control unit basically takes place of everything at this point controls the transmitter, where you want to set the power and the various parameters that you have in our smaller devices. So all at one click of a button here, LED functions over here, and OLED panel here. For the dual exciters, we also have integrated in this control unit in 10 and 15 kilowatts. We also have the auto changeover switches there, and also in the dual exciter systems, we also have the exciter dummy load is also contained within this 4RU unit. Standard for our products from 10 up to 30 kilowatt is an air extractor. Now, I like this. I mean, we've got the airflow running from the front to the back on all the units, and on the 5 kilowatt modules, there are 3 in the front, 3 in the back of the actual modules on every single one. Yet at the same time, as they go to the back of the rack, we have an air extractor here that blows everything out here. So you can either hook that up to your ducting or your ducting in your fan system and out into your ventilation system. Really critical. If you have a really hot running transmitters that we've seen in the past that are very inefficient, it's hard. You have to air condition them, and it takes quite a bit of power to do that. Now I'm going to show basically some renderings. You've seen the photographs, so these are real. It's a little bit easier to explain from the renderings here. A 10 kilowatt versus 15 kilowatt. So you can see they're very, very similar. In this particular case, the unit at the top is our Echos 3, which is an option for a system like this. This is a GSM control and monitoring device that we offer. But here are the dual exciters here on the 10 kilowatt, dual exciters here on the 15. Here's my controller unit, and here again I have the integral dummy load and the changeover switch. Here the same thing here. And then I have 2 because it's 10 kilowatt, and here's 3. Now, also with this, we have our breaker panel, which is really important. And I should point out that in the case of being able, say, in the unlikely event you would have a failure of this power amplifier, you need to change something, you could turn off that breaker here, okay, disconnect some of the components here while keeping still transmitting. You're still live on air. I can pull this out through the front, put in the new unit, make up all the connections again, connect up the breaker panel, and boom, I can slide up to 15 kilowatts again. So, to an extent, it's not true hot swappable, but it's certainly not to the point. You don't have to take the transmitter out to replace any of the components in the system. Okay, here's some examples. I know there's a gentleman in Indonesia who would be happy to see this photo, and we can't say that installing this and operating is complete child's play, but you can see the size and compactness of a single exciter-based 10 kilowatt system. My combiner, here's my 2 PAs here, 5 kilowatt, but just you can see this 4-year-old child standing next to a compact transmitter. And to the left, here's my drawing with 2 exciters. Okay, on the 15 kilowatt, as it's part of the group that I just presented, I wanted to go in and talk a little bit about how we the schematic, those of you engineers that like to deal with schematics. What's going on here? Okay, here's my two exciters. So I've got exciter 1, exciter 2 on the block diagram. Over here is my changeover here, which is actually done in this control unit. Splitter is there. Okay, here's my E5000, number 1, number 2, and number 3 here. Here's the combiner, which is again up here. Okay, all of this is being monitored, and all my telemetry is done here through this system here. So here's my combiner, and everything goes outside through the antenna here at this point. And then, in fact, the dummy load here as well. Okay, moving on to a 20 kilowatt. You can see basically a little bit difference here in that with the 20 kilowatt, I'm adding on a fourth power amplifier. But here, this is the separation of the combiner and what we call a power box, which is basically the control unit for the system. A little bit bigger control panel here because I have more units to be able to run. Here's our 20 kilowatt in reality. You can see the back of it and the wiring that's done. We do all the wiring, everything, the complete airflow of the system. You can see a nice handy panel in the back for access to all the connections here. But we do the complete setup, and we ship them in complete racks and put them in crates, and boom, they go off to you. You take them out of the crates, pull off the protective water covering, and either casters or without casters, just roll it into place and hook it up to your antenna system and connect up your AC power, and away you go. So power in these are, in fact, all three-phase, and three-phase 220 or three-phase 380. Okay, trying to find my cursor here. Okay, here's a 30 kilowatt. So again, the same concept of scalability. We're adding another power amplifier. We have a 6-way combiner here. You can now get the story. I've skipped over a 25 kilowatt. There's a 25 kilowatt that has a 5-way combiner, but in this particular case, boom, we're up to 30 kilowatt, and away we go. I'm going to start showing some differences in what kind of coverage you get out of the powers also, so you get a feeling for what changes between 5 kilowatts up to 30 kilowatts. Here's a nice photo of us in, well, we have Mr. Danielle Prosperini here, and one of our customers, and Mateo at NAB in Las Vegas, and we introduced the 30 kilowatt there. So it was an exciting time. Came by and took a look at 30 kilowatts in one rack. Okay. I should want to point out also that a lot of you may have want to do something like a 1+1 system. Maybe you want to do a 10 kilowatt plus 10 kilowatt backup. Maybe that's your requirement in your country. Some countries have that requirement where you have to do that. Maybe you have a 10 kilowatt, maybe you have a 5 kilowatt backup, or 30 kilowatt and a 10 kilowatt or a 20 backup. All up to you how you design your system and how safe you want to be with your engineering. But I want to talk about the Elenos N+1 changeover unit. We call it the Echo 6, and the Echo 6 can work with any manufacturer's transmitter. So if you have this old tube rig that you like from the past, and you want to use it as a backup system as you get your new Elenos transmitter, surely we'd be able to connect up to it and use it as a backup. So this unit comes in configurations for up to 6+1 for N+1 systems, or there's actually a 3+1, or the 1+1 operation, which is just straight main alternate on standby. We provide priority level configurations. So in priority level configurations, you can say, well, in a 6+1, my priority is this system number 1. And so if 2 units fail at the same time, then I'm going to prioritize 88.2 megahertz over the other ones, or a specific radio channel. These are very simple to install. When you're talking about changeover units, you're talking about being able to change over the RF portion at the same time the audio. So if you're using MPX for your stereo, or you're using digital type or left-right stereo input, there's different switchboards to be able to connect up to this unit. It'll switch the RF and it'll switch the audio at the same time. Again, easy to install, but at the same time, everything that we do, including transmitters in this, all has complete remote control. So if you want to do this from the transmitter site, or you want to do it from your home on an iPad, or you want to do it from your computer at work or something like that, everything is all fully local or remote controlled. Here's just a quick shot. Everybody that's in RF loves to see these big flanges and so forth, and it gets exciting when we get up into the higher powers. No different than our standard e-boxes that we've used before, with where you get a web type interface. Well, in this particular case, here's an EBox integration here with an N+1 system. So our N+1 systems are really quite unique. The lower ranges, we can put a whole 6-foot-1, 2 kilowatt system in 19-inch rack. Pretty cool stuff. Again, remote control and monitoring. I think it's really important to be able to, basically these transmitter site, you can leave them alone for a while, but if you want to look at things, my power and my reflective power, let's keep looking at frequency and record these on a regular basis, efficiency measurement, power supply voltage, current of the power supply, and here's even my temperature, max temperature of the system, or the environmental temperature. So this is pretty common here, and that you'll see a slight increase from the outside temperature compared to the equipment. And I can tell you, typically, without an IceFET technology, you see about a 10 to 15 degree difference inside the enclosure compared to what we're seeing here. For what we call total control, it's our EBox SNMP web interface, along with our Echoes 3, which is the GSM type management as well. More on that another day, or in one of those seminars. So talking a little bit about the digital exciter option that will come with the lower power systems, or the medium power systems, or into, in this case, 10 kilowatt. And again, it's direct channel with standard, with AES CBU, with sync network option, and also there's the capability as our countries transfer into the digital world and go DRM, DAB, or HD. So, okay, that is the end basically of our part of the webinar that's talking about the equipment. And I think you can see that it's basically very, very simple building blocks. If you understand our products in the lower power ranges, it's easy to see how with the scalability we can assume 10 kilowatt up to 30 and beyond to 40. What I wanted to do is I thought, okay, I get these questions a lot of time. Do I need a 10 kilowatt or a 15? Do I need a 20? What's the difference between a 5 and a 10? Well, okay, I took an example here, and I took using a tool that I use to basically look at antenna coverage with using types of antennas, where it's vertical or circular polarization, or with different numbers of bays and different powers. And basically, I go by this criteria, basically, whereas the criteria, basically, the strength to provide a good stereo signal is 54 dBu per microvolt per meter. In rural areas, in suburban areas and city areas, this is where it gets critical. So as you can see, it starts getting a little bit more difficult because I have a lot of reflections and a lot of cement and concrete to penetrate as I get into areas like this. Rural, it's a lot easier. So this is going to remain probably the key point in what we see, when we do our coverage maps, okay? For mono reception, I mean, you can go way out, there's hundreds of kilometers, you're still getting good mono reception. It may not be the greatest stereo reception, but you'll still get 6 dB lower than even like 54. So I can consider down into the 40s dB per microvolt, I'm getting coverage. So you got to consider that as well. Okay, so I'm going to start out with, let's look at 1 kilowatt. This coverage map is Phnom Penh, Cambodia. And I took 1 kilowatt, and this dark area here refers to 75 to 100 dBs per microvolt. And then the blue area here, again, is 60 to 75. So according to the guide that I had previously, this gives you an idea. This is really what we're looking for, is these areas here. As we get out into the fringes here, the coverage is a little less dense, but still we have coverage, so it's important to see that. Let's increase to 5. You see 5 kilowatt. You can see that my inner areas increase. So the 75 to 100 is the ideal range, and here 60 to 75 as I move out into the suburban areas is looking quite well. Now I jump it up to 10 kilowatts, so I've doubled the power, the 3 dB, and you can see the shade again increasing here. So this is just a reference to give you an idea. I move up to 15 kilowatt, then to 20. There's 30 kilowatt gives you for Cambodia, and as you can see, I'm starting to cut into areas of Vietnam here, and let's see, this is looks like it's going into parts of Thailand as well. So coverage is quite enormous for a 25 kilowatt. Get into 30 kilowatt, and even more so. So again, impressive, but then let's take a look again at the center. This is what you get for inner city. The way to go is with the higher power, so you can be self-assured. I can do a lot of things. I can do it with antennas. I can do it with more high power for the transmitter. Again, there are tricks if you talk to transmission and systems integrators, what I can do with the antenna again to get better coverage. But given the tools of a 30 kilowatt transmitter down to a 10 kilowatt transmitter, there's a lot of things you can do with coverage here. So, and here's a comparison you can see. And I think it's really quite interesting that, you know, at first glance, it really doesn't look really that different when you go from 5 compared to 30, but it is quite different if you start looking at the inner areas and look at really getting good stereo quality in these areas. So, that basically concludes my part of the presentation, and